Hello, this is Paul from Foresight Tech. In this lecture, I'm going to introduce indefinite integrals, and I will use the definition to evaluate the indefinite integrals. And the major one later, I will going to introduce the basic formulas. Okay, and the first, what is the definition for indefinite integral? We already learned what is the definition for definite integral, right? Which means the area under a curve. So what is indefinite? So here is the definition. The first one is the notation for indefinite integral. See, we don't have limits here. And the definition is defined by capital Fx. What does this mean? This means the derivative of capital f functions take a derivative goes to f, which means what? Definitely. And this capital Fx is just n derivative or n derivatives, okay? Any n derivative is the definition. So we have a lot of n derivative. And this is important, this definition. Why? Because we learned the fundamental theory of calculus last class, right? If we know the n derivative, and then we can find out what is the definite integral. So here indefinite is just the n derivative, okay? Definition is like this. Now we need to look at the basic formulas and a lot of formula later. So all the formula is just based on the basic derivative formulas, okay? Basic derivative formula you learned from Calculus 1. So one by one. So the first, see, and what does this mean? This means c times fx are going to find the nth derivative. The nth derivative should be, we can factor c out. Factor c out. Why? The reason is here. If we say capital Fx is the nth derivative, okay, is one nth derivative of lowercase fx. See, this means what? The right is c times capital Fx is the nth derivative of this. We're going to verify c times capital Fx take a derivative. Of course, we can factor c out, right? And equals the c times derivative of fx. Derivative of f is lowercase fx. So therefore, the right side take a derivative goes to the integral function. Yeah, definitely that's the definition, right? All the others is follow the same formula. Okay, so follow the same way we're going to prove. What is this? This is a constant function. Okay, so the first, and this we call the constant multiple, right? Constant multiple. All this is also constant multiple rule for derivative. Okay, so the second formula is k. K is a constant number. This means we're going to find the derivative for a constant function. What the constant function is a linear function. Why? Because we take a derivative for a linear function can goes to constant, right? Definitely. So here is the third one is a power function, right? Power function, of course. So the power is not equals to -1. Okay, the next formula will show the power is -1. If the power is not a -1, and then is the nth derivative still goes to power function, and the power goes to 1 more, and divided by n plus 1. Why? Because this take a derivative goes to xn. We learned this, right? We used this last topic. Okay, look at all this. Why we plus c, and this is only one nth derivative, and for the definition for indefinite is all nth derivatives. Okay, so we plus constant number c goes to all the nth derivatives. And here, and the next one is just for the power is -1. If the power is -1, this is a reciprocal function, right? How to find the indefinite integral or the nth derivative? This nth derivative is a log function, the ln, natural log, but we have an absolute value of x. Okay, of course it's plus c. Why? Because from Calculus 1 we learned that this take a derivative goes to reciprocal, right? Okay, so we go to the next page. The other more functions, okay, more formulas. We look at this formula. These two formula both we deal with the antiderivative of exponential function, right? This is the natural exponential. So this equals itself. Of course, it's plus c. Why? Because itself and this function take a derivative equals itself, right? So this take a derivative goes to the integral function. That's true. Okay, means what? Means this exactly is the antiderivative. See, and if it's not natural, okay, this time we have a little bit of change. We need to divide it by ln at the base b. Why? Because from calculus we have basic b raised to the x power, take a derivative goes to b raised to the x power times ln b, right? If times ln b divided by ln b, of course is b raised to the power of x. Means this definitely, or this total definitely is the capital F, or the antiderivative of b raised to the x power. Try to memorize all these formula we have to use in Calc 2. Very important in Calc 2. One by one, we're going to trick a function. So here, what is the antiderivative of sine? It's not a cosine. Why? Because the cosine take a derivative goes to negative sine, so it's negative cosine. Negative cosine take a derivative goes to sine, right? Okay, another was the antiderivative of cosine is sine, because sine take a derivative goes to cosine. So here was the antiderivative of secant square, which means the secant square of x. Okay, secant square is tangent, because from Calc 1 we have tangent take a derivative goes to secant square. Okay, what is cosecant square? Cosecant square is not a cotangent, but a negative cotangent, because cotangent take a derivative goes to negative. So negative cotangent take a derivative goes to positive cosecant square. So this is the antiderivative. A few more. Look at it. So how about this? These two diatric functions. So this is the multiplication, right? Secant times tangent is famous. The antiderivative is secant. Why? Because secant take a derivative, we have the formula. The basic derivative formula for secant is secant times tangent. Okay, so we have this from Calc 1. So what is cosecant times cotangent is negative cosecant, because cosecant take a derivative goes to negative. See, so negative cosecant take a derivative goes to positive. Cosecant times cotangent. I hope you go over these formulas we learned from Calc 1. Two more formulas for inverse trig functions. Inverse trig functions. We look at what is the derivative. So we look at what the derivative of inverse tangent. Inverse tangent take a derivative goes to 1 over x squared plus 1. Okay, so means what? And 1 over x squared plus 1 has the antiderivative of tangent inverse tangent. Okay, so the antiderivative of 1 over x squared is tangent inverse tangent. The same. 1 over square root of 1 minus square x squared. See, that's the formula. So inverse sine take a derivative goes to 1 over square root of this. If we have this, means inverse sine is 1 of the antiderivative of this, and then plus c is all the antiderivative. And that's the one here for the basic is the hyperbolic functions. We have a lot of hyperbolic functions, of course. And the same, we have a lot of inverse trig function, right? But we only take these two. We call it the basic. Two basic for hyperbolic functions. How to find the antiderivative? Okay, so this is very easy way. The antiderivative of hyperbolic sine or sine h, okay, is cosine h. Why? Because cosine h take a derivative goes to sine h. Okay. And the same, sin h take a derivative goes to hyperbolic cosine. Therefore, sin hx is the antiderivative of cosine hx. Okay, and so far that's all the basic formulas. See, we have a lot of formula. So I hope you try to memorize all these formulas as early as you can. I think you know this, right, from Calc 1. And now I give you just one example. We'll look at this example. Okay, so the first example, and then we look at this integral function. How do you find the antiderivative? And this we call the what? No limit means antiderivative, or we call the indefinite integrals. And this is complicated. Okay, it's a combination. It's a combination of functions. We need to simplify this first. I mean, it's not like a power function. It's not a power function. It's not an exponential function, not a cosine, sine, trig function, inverse trig, hyperbolic, no, but it's a combination of something. So can we look at it? If we change this a little bit, okay, I put it here. This one should be equals to, this is a combination of a fraction, right? We can separate the fraction into this. We'll get the easy, okay, this is too complicated. We're going to get the easy. 1 over x is 1 over x, of course. Square root of x over x, rather one more step, okay, plus this. Square root of x over x plus x over x dx. Okay, move on. In this way, we can get a simple for this integral function. So the first is 1 over x. The second was this. Okay, this is we're going to get a square root of x to the bottom. Square root of x is 1/2 power, right? So it's better to write this. It's better to write a power. So this is a half. This is a 1 half. 1/2 minus 1 is a negative 1/2. I think you know this. And then this is a 1. And then dx. So now what we can do? Remember we have a sum formula, right? So we have a sum formula. I think I should do the sum formula. Okay, I think I did not put the sum formula there, right? Yes, I did not put the sum formula. So let me put the sum formula here. I put the sum formula to here. So we have a sum or difference formula, which is this. If we're going to find the f for x plus gx, okay, what does this mean? Okay, we're going to find the antiderivative of f plus g is just going to do this. Find the antiderivative of f, which is this, right? Antiderivative of f plus antiderivative of g. Okay, this we call the sum. If it's negative, so it's the same. See, if it's a minus, so we put a minus this. So this is another formula. Okay, I did not put it to the basic. This is a basic, or we call the sum or the difference formula, right? Why we have this? You can imagine why we have this. Because this take derivative goes to this is capital if I wrote it here. Why this is correct? Because capital Fx plus capital Gx. If this capital F is antiderivative of Fx, capital G is antiderivative of lowercase g, and then we're going to see. And this take a derivative. What goes to what? What goes to derivative of f plus derivative of g, and then what is? So this is lowercase f, this is lowercase g, definitely is, right? The same if we put the negative here, and we will change negative here. I mean, this is the sum or difference formula is exactly true. Now we will have this is the sum formula, right? We have 1 term, 2 term, 3 term. We can separate it into 3 antiderivative or 3 indefinite integrals, and then one by one. So the first, if I wrote this like this, 1 over x dx is the first. The second is x negative dx. The last is 1 times dx. So now we can get the answer, right? So the first, this is reciprocal. We just have a formula. So the first is a ln function, right? The ln x, but don't miss absolute. Plus c, plus c1, plus c2, plus c3, all the constant number we put to the end. Okay. So the second is going to plus, and the second is a power function, right? This is power. So what do we need to do? Raise to the power plus 1, which is 1/2 x raised to the 1/2, which is square root of x, and then divided by 1/2, which means times 2. Use the power, which is 2 times square root of x. The third one is 1 constant number. Remember, it's the linear function. 1 times x, which means x. X take a divided equals to 1. This take a divided equals to there. This take a divided equals to reciprocal. Don't miss the last. Plus c. Why? Because plus c goes to all the end divided. This is the first one. We're going to do the second one. But look at one more. So this one is easy. We have the sum of difference rule, right? Okay, so now we're going to separate it into sine x dx. This is the end derivative. Plus the second sine h x dx. This is the sum rule, right? And then one by one. Sine x, we have the end derivative is not a cosine, it's what? It's negative cosine. Plus c, we put it to the end. What this? This time, this is exactly cosine h, hyperbolic cosine x. This take derivative to there. Don't miss the last, is plus c. Okay, so that's all. Thank you.